Hi there, this is Mr. Schnitzius, and in this video we are continuing to work through activity 26. This is lesson 26-3. We're still writing coordinate proofs, and in this video we're going to prove that the medians of a triangle are concurrent. So this is on page 383 if you're following along with the electronic PDF. So let's read this introductory statement. When writing a coordinate proof, it is helpful to think about what you know about the concept at hand before delving into the proof. Getting an idea of the big picture will help you organize a step-by-step method for proving the conjecture or theorem. A group of students has been asked to write a coordinate proof of the following theorem. The medians of a triangle are concurrent. So we're going to start out by writing what we know about the medians of a triangle. We know that the medians of a triangle are concurrent. What does that mean for segments or lines to be concurrent? Well, it means that they intersect at one point. So our goal for this proof needs to be to show that all three medians of a triangle intersect at one point. So in this particular proof, there are four different steps that we need to do. We're going to list these out in a logical step-by-step order. The first step is going to be drawing a triangle and its vertices. After that, we're going to identify the midpoint of each side of the triangle, since the median of a triangle connects a vertex to the midpoint of the opposite side. Then we're going to write the equation for each of the medians, and we'll do this with point slope form. We'll know each median slope and a point that's on the median. Lastly, we'll determine the point at which the medians intersect. So this is going to involve a fair bit of algebra. This algebra is not going to involve a lot of numbers. It's going to involve a lot of variables, but we're going to go very slowly, step by step, through each step in the algebra. And of course, since this is a video, I would recommend jotting down this algebra in your notes. And if you need to pause the video, rewind it, make sure that you understand each step, then that's a good studying strategy. All right. So the first thing that we're going to do is draw a triangle, XYZ, with vertices x at 0, 0, y at 2b, 2c, and z at 2a, 0. All right, so there's our triangle. We have 2 points that are on the x-axis, so that we end up with some zeros. So that'll make our algebra a little bit easier later on. All right, so we're going to write the coordinates of the midpoints for each side of the triangle. The midpoint for x, y is going to be, well, to get the x coordinate, that would be 0 plus 2b divided by 2. 2b divided by 2 is just b. And the same thing for the midpoint, the y value of the midpoint of segment xy, that's going to be the point BC. 2c divided by 2 is just c. So you might have been wondering at the beginning, why 2b, why 2c, why 2a? It's so that we get a nice easy midpoint. So here's the work for the midpoint of segment YZ. Add together 2a plus 2b, cut that in half. Once you factor out the 2 in the numerator, you get just the quantity a plus b. 2c plus 0 is still 2c divided by 2, so we get a plus b comma c for the midpoint of segment YZ. And for the midpoint of segment XZ, that's the midpoint of this segment along the bottom. Well, obviously, the midpoint is going to have a y value of 0, just like it does right there. 0 plus 2a divided by 2 is a. So here is what the midpoints look like. And then we've got all of the medians right here where the intersecting in one point. So this point right here where the medians all intersect, that point is the centroid. And what we're trying to prove is that no matter what the coordinates are for x, y, and z, the medians will always intersect at that one point, the centroid. If we can show that all three of these lines intersect in the same spot for these general points, then it'll work no matter what values we choose for A, B, and C. Okay, so that's our goal. So we're going to write the equation of each median. First, we're going to write the equation of median number 1 using the points B, C, and 2A, comma 0. That would be the equation for this median right here. I'm going to put that one in purple. So our expression for the slope is going to be found using the slope formula. We've got y2 minus y1 divided by x2 minus x1. So 0 minus c is negative c. And in the denominator, we get 2a minus b. So we're going to use the point 2a comma 0 to write the equation for median 1. So let's see. Remember, this is point slope form. So it's y minus the y value of our point. So this y value of 0 is being plugged in right there, equals the slope times x minus the x value of your point. Okay, and then to get from this step here, this original step down to here, we're just doing the distributive property. So the slope times the x, and then negative c times negative 2a gives us 2 times ac. All right, so we're going to do the same thing now for median 2 using the points a comma 0 and 2b comma 2c. So that's going to be the median connecting point y to its opposite midpoint. So same steps as before. Find the slope. So it's y2 minus y1 divided by x2 minus x1. So that's in the numerator 2c, in the denominator 2b minus a. So we're using our slope that we got in number 7, part B, and the point 2a comma 0 to write the equation of median number 2. So we've got y minus 0 equals the slope times x minus a. So we're still using this point from up here. I'm sorry, that's just the point a minus 0. We're not using that point. We are using a comma 0. So we take our x value from the point and we subtract it from x. We take our y value from the point and we subtract it from y. Here's our slope that we just worked out up here. Now we're using the distributive property. So it's 2c over 2b minus a times x. And then when we multiply 2c times negative a, it gives us that negative 2ac in the numerator. All right. Lastly, we're going to use the point a plus b, comma 0, and 0, 0 to find the equation of median number 3. So we're going to put that one in red. And unfortunately, that should be, as you can see back here, that's a plus b, comma c. So we're going to change that to c. See, they put it correctly when they worked out the slope. So sorry about that. Textbook writers are people too, just like teachers are. So this is y2 minus y1 divided by x2 minus x1. 0 minus c divided by 0 minus the whole quantity a plus b. So those two negative signs cancel out. We get a slope of c divided by a plus b. So I believe that we're actually using the point 0, 0. Again, sorry about that. So y minus the y value of the point equals the slope times x minus the x value of the point. Since that's just a 0 right there, it's easier once we do the distributive property. So these are our three equations for the median. So our job now is going to be to find a way to prove that all three medians contain this point of intersection. So let's see how we're going to do that. Find the point where two of the medians intersect. Choose two of their equations and find their intersection point. So it looks like we're doing, it looks like we're doing the equation for median 3, and we're also doing the equation for median 2, the one that has positive 2ac over 2a minus b. So we're going to set these two equations equal and solve for x. In other words, we're going to try to find the x coordinate for this centroid right here. Now, we're going to look at this step by step, just a little bit at a time. See, we're using the substitution property to set these two equations equal to each other. If they're both equal to y, then whatever's on the right side must be equal to each other. Now, the first thing that we're doing is we're taking this negative term and we're moving it to the other side of the equal sign, right? You can imagine showing your work by putting plus c over 2a minus b times x on the left side and that canceling out and that moving over to here. Okay? So now what we're going to try to do is get a common denominator. Since these three fractions only have two different denominators, one denominator is 2a minus b, one denominator is a plus b. If we multiply the left-hand side and the right-hand side by that least common denominator, that 2a minus b times a plus b, well then we'll get this 2a minus b to cancel out with this 2a minus b over here. So what does that give us? On the left-hand side of the equation, that gives us 2ac times a plus b. All right, what we did now is we did the distributive property. So we took this whole expression, we distributed it to the c over a plus b times x, and we also distributed it to the c over 2a minus b times x. Now when we did that, since we had an a plus b in the bottom and we multiplied by a plus b, those canceled. The same thing happened with the 2a minus b in the second term and the 2a minus b that we multiplied by. So now we've got, after all this cancels out, we've got 2ac times a plus b times cx, didn't get canceled out, times 2a minus b, plus cx times a plus b. See, this whole expression is much, much easier now that we don't have any fractions, now that we don't have any denominators. Well, remember, the whole goal in doing this was to solve for x. In other words, get x by itself. So now we're doing the distributive property. Distribute the c times x. Distribute the c times x. And what you might notice there is we've got some like terms that we can combine. You might also notice that this is negative bcx. This is positive bcx. So this is about to look a whole lot nicer. Those cancel out. Those go away. So what we're left with is 3acx. All we have to do to get x by itself is divide both sides by 3ac. And then on the right side, that cancels out. On the left-hand side, the a times c in the numerator cancels out with the a times c in the denominator. And we're left with this expression for x. Now remember, the whole point of doing this was to find the coordinates for this centroid. So in terms of A, B, and C, we found that this centroid has coordinates 2 times A plus B over 3. But we don't want to just know the x value for the centroid, we want to know the y value of the centroid also. So in order to get that, now we're going to solve for y. So we're going to plug our value for x into one of these two equations. This equation looks a whole lot easier. So we're going to take what we got for x, and we're going to substitute it in right here. That'll tell us the y value for the centroid. So let's see what we get whenever we do that. Well, right away, you might notice that we get some common factors that we can cross-cancel. So what are we left with? We're left with 2c over 3. So that tells us that the point where these two medians intersect is at this point right here. 2 times a plus b over 3, comma, 2c over 3. In fact, just to make it clear what exactly it is that we know now, that gives us the x value and the y value for the centroid. Well, see, now we know that that's a solution to median 1 and median 3, but we need to check to make sure that it's also a solution to the blue median. Because remember, to be concurrent, all three medians need to intersect in this one point, not just two of the medians. So how do you make sure that a point is a solution? Well, you plug it into the equation and you make sure that you get the same statement on both sides. So since this was median number 2 that we labeled in blue, our job now is going to be to substitute. See, we're going to take what y is, and we're going to plug it in right here. We're going to take what x is in that point, we're going to plug it in right here, and we're going to try to get the same value on both sides of the equation. So here's the value for y getting plugged in, 2c over 3. Here's the value of x getting plugged in, 2 times a plus b over 3. Everything else just comes down. So what are we going to do? What did we do last time that was really helpful? Well, it was helpful last time to get rid of the fractions. How do we do that? We multiplied both sides through by the least common denominator. So we're going to multiply both sides through by 3 times 2b over a. So we're going to end up with some values that cross out. Those 3's can cancel. Those 3's can cancel. Those 2b minus a's can cancel. And over on the very right, we have some 2b minus a's that can cancel. So that's everything canceling out. What's left when we clean everything up? Well, on the left-hand side, we're going to have 2b minus a times 2c. On the right-hand side, this 2c can come down. This 2 times a plus b, after we do the distributive property, is going to give us 2a plus 2b. And then in the last term, we've got a minus 2ac that comes down. That gets multiplied times 3. Well, now, since we have no more denominators, hey, that's really great news, we can do some distributive property. 2b gets multiplied times 2c. Negative a gets multiplied times 2c. Here on the right-hand side of the equal sign, 2c gets multiplied by 2a and by 2b. So let's look at what we end up with after that. 4 times bc minus 2ac equals 4 times ac plus 4bc minus 6ac. Hey, remember, our goal is to show that this is a solution. In other words, plug it in and get the same value on both sides of the equation. Just like you did in Algebra 1 class over and over and over again. Well, this is looking pretty good for that because I've got a 4bc here, I've got a 4bc here. When we combine together 4ac minus 2ac, we end up with the same, with the 4bc minus, when we combine the 4ac minus the 6ac, we get negative 2ac. There we go. So we've got the exact same value on both sides of the equation. If we subtracted 4bc on each side, those would go away. If we added 2ac on each side, those would go away. So we've got 0 equals 0. We've got the same value on both sides of the equation, so it is a solution. This centroid lies on the equation of all three medians. So that proves that 2 times a plus b over 3, comma 2c over 3, that centroid point is a solution to all three equations. So that proves that the medians of a triangle are concurrent because they all intersect at the same point. Now, before we kind of wrap this up by looking at a couple of problems, there is not going to be a question on the quiz or on the homework that involves this much algebra. So don't let that stress you out, okay? When you get into pre-calculus or calculus, you'll be looking fairly regularly at problems that involve this level of algebra, but this is just meant to give you a look at what a more advanced coordinate proof can look like. Okay, 2 problems to make sure that we understand this on the bottom of page 386. Describe a benefit in a coordinate proof of placing one of the edges of the triangle along the x-axis. Well, we talked about that at the beginning of the video. Then 2 of the 3 vertices have 0 as the x-coordinate. That gives us fewer variables in our work, and it gives us an easier expression to manipulate. So if point T is the centroid of triangle QRS, write a summary about the properties of point T. So point T lies always within the interior of the triangle, and it is the point at which the medians of the 3 edges of the triangle intersect. So this is the type of thing that you want to be able to understand on your homework and also on your Unit 4 quiz and on the final exam. This is another good way to remind you about the important properties, not only about centroids, but also in your homework there's a question that asks you to remember some of the facts about the points of concurrency for the angle bisectors. And you also want to be sure that you remember where all the perpendicular bisectors in a triangle intersect and where all the altitudes in a triangle intersect. All right, thank you guys so much.